Hey guys, welcome to your Unit 4 Lesson 6 notes on inverse variation. Last time we talked about direct variation, here we're going to do the opposite. By the end of the day, you'll be able to solve problems involving inverse variation, and here is one. We have 5 rectangles here. You'll notice the first one is 2 squares wide by 6 squares long. Which means it has a total of 12 squares inside. This next rectangle is 3 squares wide and 4 squares long, which means it has a total of 12 squares inside. This rectangle is 4 squares long and 3 squares wide, which means it has a total of 12 squares inside. This rectangle has 6 squares long and 2 squares wide, which means it has a total of 12 squares inside. And finally, this last rectangle is 12 squares long and 1 square wide, which means it has a total of 12 squares inside. So you notice that each of the rectangles shown has an area of 12 square units. And as the length increases, the width decreases. That is, as it gets longer, it gets less wide. And the opposite is also true. As it gets shorter, as the length gets shorter, the width, in fact, increases. However, their area increases. Their area always stays the same. That is, their product always stays the same. This is an example of what's called inverse variation. Last time we looked at direct variation, which is where you have y equals k times x. This time, inverse variation says y equals k divided by x. There you have it. That's the whole lesson. Bye. I'm just kidding. Let's do some examples. So an inverse variation is described by an equation of the form that we just wrote. X, y equals k. Ta-da! Or if you solved for y, if you took x, y equals k and you divided both sides by x real quick, then y equals k divided by x. I think that this is the easier way to remember it, but this is how we define it, so there you go. Okay. So remember yesterday when we talked about direct variation, we say that y varies directly as x. That is, whatever our x is, our y is going to increase when it increases, and at a steady rate. So we say that y is directly proportional to x as well. However, when you have an inverse variation, as x increases, y decreases. So y varies inversely as x, and we say that y is inversely proportional to x. Also notice that in a direct variation, it's a straight line, but in an inverse variation, it's this curvy guy right there. So that's fun. And then finally, our two formulas. In a direct variation, we say y equals k times x, but in an inverse variation, y equals k divided by x. So let's look at an example of what inverse variation is. So would you look at that? Okay, the number of carpenters needed to frame a house varies inversely, wherever we see varies inversely, right? Y equals k divided by x. Okay, the number of carpenters needed to frame a house varies inversely as the number of days needed to complete the project. Suppose that there are 5 carpenters. Suppose 5 carpenters can frame a house in 16 days. How many days will 8 carpenters take? Oh, this is a classic problem. To frame the house. Assume they all work at the same rate. Classic. So just first look at it. Here we have 5 carpenters in 16 days and then 8 carpenters. Is it going to take more time or less time? If you have 8 carpenters, you have more carpenters working, it's going to take less time overall. So it should take less than 16 days. This is our little reminder to ourselves to see if we did it right. Okay. Now remember that how long the project takes depends on how many workers you have. So we're going to let the length, or rather the number of days, be our y, because that's our dependent variable. It depends on x, which is the number of workers. Oh, it's number of carpenters. So now we need to find the constant of variation. We remember our inverse variation formula says that y equals k over x. So we're going to plug in what we know for our x and our y. Well, we know that 5 carpenters can do this in 16 days. And our carpenters are our x, and our days are our y. So let's plug those guys in. So we know that 16 equals k divided by 5. To solve for k, we need to multiply both sides by 5. So we get that k equals 80. Does that mean it's going to take 80 days to build this house? No. That means we know the constant of variation. So we can write our formula, y equals k divided by x, but this time k equals 80. So y equals 80 divided by x. Now we wanted to know how long will the project take with 8 carpenters. Remember, carpenters is our x, so we plug that right back in. How many days will it take when x equals 8? So y equals 80 divided by 8. Oh, that's pretty straightforward. That's just 10. So it'll take 10 days. It will take 10 days. Yay. Now let's go back and check. What was our original estimate? It needs to be someplace less than 16 days because we're working faster than the 5 carpenters. Is 10 less than 16? Yay, it is. We did it. Good job, guys. Okay. You can also use proportions with inverse variations, but you guys, it's really messy, and I don't encourage you to do it. I would prefer that you rather stick with y equals k over x and then just plug in what you know for x and y to help you find k. This is the way to go, to just use the equation. The equation is better. But if you want to use a proportion, then you'll need to set up your 2 different points. You'll need to, just like last time, you'll need to have a point number 1 with an x and a y, and you'll need to have a point number 2 with an x and a y. We call these x1, y1, and x2, y2. You have your x's and you have your y's, right? Make wise choices. But then things get kind of wonky. If you have your x's on top and your y's on bottom, see how we have x's and y's, then your points need to switch. Then you need to have, your point 1's on opposite sides of the equal sign and your 2's on opposite sides of the equal sign. So they need to make an x to each other the whole way around. Something needs to make an x to each other. here we have our x's lining up with our y's like this, but then our coordinates from our second point and from our first point, they make cross products. Can you see how that's going? That's getting, oops, it's getting messy, and I don't like this method at all. But I'm going to present it to you because maybe you like it. Maybe you want to set up a proportion, and that's fine. All the power to you. But it will do the same thing as this equation. So let's use this equation to help us. Suppose y varies inversely as x. Remember, we have varies inversely. So that's this guy right here. And y equals -6 when x equals -2. Find y when x equals 3. So first we're going to plug our x and our y into our equation to find k. So what do we know? We know y is -6, and we know x is -2. Wrong color. X is -2, and now we need to find k. Good? Good. So we'll multiply both sides by -2, and that'll give us that 12 equals k. Now that we know what k is, we plug that back into our y equals kx, but this time we find y. So we take 12 and we plug that in for k over here. We don't know what y is yet, so we have y equals k is 12 over x is 3 this time. And then we just solve. 12 divided by 3 is 4, so y equals 4. Yay! Okay, one more problem. Let's say you have a race car, which is a palindrome, because R-R-A-A-C-E-E. So that's fun. Tell Mrs. Luffle. It's traveling 125 miles an hour, and it completed one lap around a racetrack in 1.2 minutes. How fast was the car traveling if it completed the next lap in 0.8 minutes? Let's see. Well, let's look at this. The car was traveling and completed the next lap in 0.8 minutes. So if it took less time, we want it to be faster. So its new speed should be faster than 125 miles per hour. Now let's do our problem and see if it makes sense. Okay. So first we need to find out, what's the distance this person was traveling. So we have distance equals rate times time. Well, we know at first it was traveling 125 miles an hour. So our rate is 125 miles per hour. And our time was 1.2 minutes. Times 1.2 minutes. So what is that? That's 150. So our distance is 150. Now we need to find the rate of the second lap. So if we know distance equals rate times time, and we know our distance is 150, we're looking for our rate. So we don't know. We'll call it R. But what was the time on that second lap? It was 0.8 minutes. So we have 0.8. That is R times 0.8. So to get R all by itself, we're going to divide by 0.8 on both sides, and we get 187.5 equals R. That means the car was traveling at a rate of 187.5 miles per hour. And is that faster than 125 miles per hour? Yes, it is. So we probably did something right. Cool? Cool. So inverse variation is y equals k over x. This is different from direct variation, which is y equals kx. Remember to use your inverse variation to help you solve for the constant of variation. And have a fantastic time in your homework.